Hi everyone. In this video, we are going to discuss about how to calculate the area of a triangle when any two sides and the included angle have been provided. Let's suppose we have a triangle ABC, as you can see in the diagram, where the side length AB is denoted by a lowercase c units and side length BC is denoted by lowercase a units and side length AC is denoted by lowercase b units. And similarly, angle BAC, which is the angle near the vertex A, is denoted by an uppercase A radian. Let's suppose it's in radian. And then angle ABC is denoted by uppercase B radian and angle ACB is denoted by uppercase C radian. We know that the area of a triangle is actually half times the base times the height. Now here let's take BC as the base and let me draw the height like a perpendicular from the vertex A onto the BC, and let's suppose AD is the perpendicular on BC from vertex A. So we can consider AD as the height of this triangle if we consider BC as the base. So what will be the length of AD? Well, if we look at this small triangle here, triangle ABD, from this triangle what do we get? Well, if we take the sine ratio of the B angle, so we can say sine of ABD, that is actually opposite over hypotenuse. And now what is the opposite side? Well, that is actually AD. Over hypotenuse would be AB, and from here we can find the length of AD. So AD will be equal to AB times sine of that angle ABD. Now what is AB? Well, AB is denoted by lowercase c units. So this is actually the side C right here, and this is actually the side B right here, and this is the side A. BC is the side A. So in place of AB, we can write C, lowercase c, times sine of that angle. What is that angle? Well, that angle is actually same as the angle ABC, which is actually the uppercase B. So we can say this is equal to C times sine of B. So we have found the value of AD. Now let's use this value to calculate the area of this triangle. Now area of the triangle, I am going to use a different color here. So for the area, I am going to use the delta sign here to denote the area of our original triangle ABC. So area of ABC is equal to half times the base, which is BC, times the height, which is AD, and let's substitute the values here. So this should be half times, what is the size of BC? Well, BC is actually denoted by lowercase a, so I'm writing lowercase a right there. And what is the size of AD? Well, that is actually C times sine of B. So we can say then area is equal to half times CA times sine of B. Next we are going to calculate the length of AD using the right triangle ADC. Let's take the sine ratio of the angle C, that will be equal to the opposite side over the hypotenuse. Now opposite side is actually AD, over the hypotenuse is actually AC, and from here we can say that AD is equal to AC times sine of that angle. And what is AC? Well, AC is actually denoted by the lowercase b, so that would be lowercase b units times sine of, what is the angle ACD? Well, that is the C angle. So then the length of AD can also be expressed as B times sine of C. So then if we go back to the area of triangle formula again, so if we know that the area is actually half times the base, again I am using BC as the base, and times the height, which is AD. Now let's use this new value of AD here. So this would be half times BC is actually the A side, and then AD can be written as B times sine of C. So from here we can say that the area of our original triangle can be written as half times A times B times sine of C. That's the second formula. Now we are going to derive the third formula. Now for the third formula, I am going to drop a perpendicular from the vertex B onto the opposite side AC. So we have BE, which is perpendicular onto AC, and let's assume BE as the height when AC is the base. So now if we look at the triangle ABE, it is a right triangle because BE is perpendicular to AC. So ABE triangle is a right triangle, and if we take the sine ratio of the A angle, then can we write it like this? Sine of the angle BAE, which is essentially the A angle, that will be equal to opposite side over hypotenuse. Now opposite side is actually BE, over hypotenuse is actually AB, and from here we can say then BE is equal to AB times sine of that angle, which is equal to, what is AB? Well, AB is actually denoted by lowercase c times sine of angle A. So this is the value of BE. Now let's use the same old formula for the area of the triangle. So we can say then area of the triangle is actually half times base times the height, which is BE, and if we substitute the values here, we can say this is equal to half times AC is actually denoted by lowercase b, and then BE can be replaced with C times sine of A, and from here we can say the area of our original triangle is equal to half times B times C times sine of A. So we can use any of these three formulae when any two sides of the triangle and the included angle are provided. Now how do we know that in each of the formula the angle is actually included between those two sides? Well, if you look at the diagram carefully, you will see, for example, in the first formula we have half times C times A times sine of B, and if you carefully look at it, you will see that the angle B is actually the included angle between the sides A and C, I mean the lowercase a and lowercase c. Similarly, if you look at the second formula, there you have half times A times B times sine of C, and that angle C is actually included between the sides which are denoted by lowercase a and lowercase b, and that will be the case in the third formula also, that the angle A is actually included between the sides denoted by a lowercase b and lowercase c. So looks like the area of a triangle is always like this. It is half times the product of any two sides times the sine ratio of the angle included between those two sides. I hope things are clear up to this point. Next, I am going to take an example. Suppose we have to calculate the area of an equilateral triangle where the side length is A units. Now in this case, what are the information provided here? Well, because we have been told that it is an equilateral triangle, that means each of the angles would be 60 degrees. So we can say A is equal to B is equal to C is equal to 60 degree, or even you can say pi over 3, and the side length has been provided as A. That means we can say that AB is equal to BC is equal to AC is equal to A. That's the A units. Now let's use any of these three formulae to calculate the area here. So we can say then area is equal to, now which one should we use? Maybe we can go with the first one or the second one or the third one, really does not matter. Let's go with the first one then. So delta, which is area, is equal to half times, in the first formula you can see that the area is half times C times A times sine of B, and now in this case A, B and C, they all are same because it's an equilateral triangle. So all of the sides are of equal length, and that length is actually A. So we can write A in place of C and another A in place of A times sine of the angle, and each angle again equal to 60 degree or pi over 3. So that would be sine of pi over 3. And from here, let's see, this is half times A squared times, what is sine of pi over 3? Well, that is square root of 3 over 2. So from here we can see that the area is coming out to be half times A squared times square root of 3 over 2, that will be square root of 3 over 4 times A squared, and in fact that is the area of an equilateral triangle where A is the side length. So looks like our formula is working. Even for an equilateral triangle we are able to prove that yes, the formula is working. Next, let me take another example. Suppose in this example we have been provided with two side lengths for a triangle. The side length AB is equal to 5 units and side length BC is equal to 6 units, and the angle between them is 30 degree. So now what would be the area of this triangle? Well, we can use the first formula, which is kind of like this. It is actually half times C times A times sine of B. So we can say area will be equal to half times, now what is C? Well, C is actually AB, so this is actually our C side, the lowercase c. Let me write it here like this. And BC is actually the lowercase a. It is denoted by lowercase a usually. So half times C times A times sine of B, that is our area formula. And let's substitute the values. So that would be half times, what is C? Well, C is actually 5 units times, what is A? Well, A is actually the BC side and that is 6 units, and times sine of, what is the B angle? That's 30 degree, which is pi over 6. And from here what we are getting? We are getting 5 6 are 30, and half of that, that would be 15. So this is actually 15 times sine of pi over 6, that would be 1/2. So this will be equal to 7.5, and of course you have to write it in square units because we are talking about area. Area must always be denoted in square units. So in this case the area of this triangle will be equal to 7.5 square units. So all these three formulae are very handy. You can just remember one of them and you can then easily remember the other two. It's very easy. All you have to remember is that the area of a triangle is equal to half times the product of any two sides times the sine ratio of the included angle between those two given sides. I hope everything made sense. Thank you for watching. See you in the next video.